Hello and welcome to another interview episode of the Primary Maths Podcast, the show where we talk all things primary maths. I'm John Cripwell. Maths has a bit of a reputation, doesn't it? For many people, it's something you either get or very quickly decide that you don't. And once that decision's made, it can stick for years, sometimes for life. My guest today is someone who is doing some genuinely brilliant work in challenging that narrative. I'm joined by Dominique from Sums of Anarchy, a maths communicator, creator, and co-founder of one of the most distinctive and engaging maths platforms on social media right now. Alongside her partner Jack, Dominique creates beautifully produced maths content that blends creativity, clarity, and deep mathematical thinking, all with the aim of helping people realise that maths is for them. In this conversation, we talk about why so many people feel anxious about maths, how early experiences shape confidence, and why memorisation alone can only ever take us so far. We explore the power of representations, colour and visual thinking, the difference between tricks and understanding, and why problem solving, rather than speed or rote recall, might be the most important thing that maths can give us. We also dig into times tables, fractions, curriculum choices, and what maths education needs to prioritise if we want learners not just to cope with maths, but to actually enjoy it. If you enjoy the episode, and I hope you will, please do take a moment to like and subscribe wherever you're listening, and please leave us a review. It really does help more people find the podcast and keep these conversations going. My guest today is Dominique Miranda, and I am delighted to have her on the show. Welcome, Dominique.
Hi, John. Thanks so much for having me.
Absolute pleasure. So we always start with just a little bit of background and context, really. I know, or I think I know, that you've got a few qualifications or in maths particularly, I think, which leads me to believe, given what you're doing now, that you must have enjoyed maths at school. What was maths education like for yourself when you were there?
It's a really interesting question because, I did enjoy maths at school. I think it was something that my mum really promoted to me, the importance of doing maths. There was a lot of after-school maths. I joined the QMON maths programme, things like that. So it was definitely something that was pushed in my household. And I did well at it in the classic, I got good grades, I got through, I went on to do a master's at university. So I guess in that sense you can say, yes, I did enjoy it, and yes, I was good at it. But when I got to university, I realised that part of the reason I was good at it was maybe because I was good at memorising things. Yeah. And so there were quite a few things. It was a bit of a shock to me in my first year of my undergraduate degree when I realised, oh no, that doesn't get you much further to just memorise some formula and try and apply it. You do really have to understand things, and that is the best way. And so it really changed when I got to university, how I saw my own education of maths.
It's funny, I've got a little bit of a theory that I've developed after talking to dozens of people about this subject, that there's a point at which everybody comes to realise that the maths that they're doing is sort of beyond their comfort of understanding, or it's become suddenly very abstract. And for some people that happens, quite early on. Myself, for instance, wasn't a massive fan of maths at school, ironically, given what I do now. And for some people, it seems to be A-level. Suddenly everything becomes, we've stopped using numbers and things. And then for others, go on to university or even master's degrees and stuff before they realise that actually it's harder to grasp the structure of what's happening, perhaps. I haven't come up with a name for this point, this abstraction point yet, but I think it happens to everybody at some point.
I think you're right. It should be studied, and we should come up with a name for it.
Yeah, we definitely. Well, you guys are brilliant at coming up with names for things, so I might outsource that to you, which we'll get to in just a moment. But when you think back to maths lessons at school, either primary or secondary, what sorts of things come to mind? Was it independent work that you were doing a lot of, or did it feel collaborative? Was it investigative? What sorts of things were you doing? Can you remember? Not that it was that long ago, Dominique.
It was quite a while ago now, so I'm having to really dig back. I think I don't remember there being a lot of collaborative work, which I think is a shame, because I think mathematics at its heart is a collaborative subject. I think that's how You know, it's how we communicate our ideas about the universe. That's what it is. So I'm sure it's really changed now from when I was at school, but it was very much instructional. You got information from the teacher, you applied that information, you did some questions from your book. There might have been some time where you could talk to your partner about it, but I don't really remember, apart from maybe some GCSE coursework, which maybe felt a bit more practical.
Yeah.
I don't remember many opportunities for collaborating and sharing ideas and coming up with our own discoveries.
Which is interesting given what you do now, which is all about sharing ideas and trying to find different ways of looking at things. So you are part of the team that. What's your title, Dominique?
At Sums of Anarchy, I'm the co-founder of Sums of Anarchy.
Co-founder,
it's myself
yeah.
and my partner Jack. We found the company.
Yeah, brilliant. So Sums of Anarchy, which, by the way, again, brilliant name.
Thank you.
I would love to have been there as a fly on the wall when you were coming up with different names for the business.
Well, if I tell you that one of the runners-up was Math Potato, so I think we picked the right one.
Okay, yeah, no, I think on balance, I can see why you went with Sums of Anarchy, but yeah, absolutely love that. We went slightly more on the nose with the Primary Maths podcast, but you know, two different approaches.
It says what it is. People are sure
exactly.
where they are.
I just thought if you're searching for a Primary Maths podcast, this one might be the one that you come across. So you guys have built up a huge following, increasingly large following on social media and things. For anybody that's not come across what you do, do you want to just give a little sort of overview of the sort of things that you put out and the work that you do?
Yeah, sure. So it's quite diverse, really, under the umbrella of maths, what we do at Sums of Anarchy. There's certainly a lot of maths tips and tricks. We try and help people to realise that maths is for them. No matter who they are or what their background, there's a way into it. So to that end, we share lots of different ways of doing things, and that can be anything from, you know, multiplication, times tables, fractions, all the way up to algebra. We sometimes do a bit more, you know, GCSE and A-level stuff, but we also do, we cover riddles and puzzles. We talk about the history of the subject, some of the mathematicians behind the things that we learn. I like to deep dive into the etymology of the maths vocabulary that we use. So it's all sorts of things. Anything really that takes my interest in a given week or month, I'll deep dive and hope the audience like it.
Yeah, absolutely. We do a slightly similar thing on our Aftermaths episodes. We have a little segment called Etymathsology, where we look at you've not got the complete monopoly on great names for things.
I'll have to up my game, John.
Yeah. But so how did that come about then? How did you come to think that this was what you would like to do?
So my master's is in maths and languages. So they've always been my big interests, and our background before we started Sums of Anarchy, we owned quite an unusual company, really, where one half of the company we were publishers of greeting cards. So we, you know, wrote funny titles and poems, and we illustrated and supplied those to shops. And the other side
because
were
Jack
filmmakers.
is on the graphic design side of things. That's his skill set.
Yeah, and filmmaking. Right? Yeah, he's our cinematographer, editor, and all of that side of it. So
handy. Yeah.
Exactly. And all of those skills that we picked up in that business really did apply to what we were doing. And we were a little bit embarrassed that we didn't think of doing maths videos before, given that is what I studied at university, and we perhaps had something to offer there. So when we eventually did come up with the idea, it was great because, as I say, we were able to do these really high production quality videos. I've always been a writer, so writing scripts and deep diving into things like that was something that I really enjoyed. Sharing all the different background, the different sides of it. So, you know, it sort of did all come together once we'd had the idea.
Yeah, and it's brilliant. And for anybody that hasn't seen it, the production values are fantastic, and
Thank you.
And the aesthetic as well is quite particular. Did you already own all those T-shirts, or did you buy those in especially? That's the big question.
The T-shirts have been a growing entity. I did have an embarrassingly large amount of them, and then when we realised that it was another edge that people did enjoy, I'm wearing that, I don't know if you can see it, it's Doug today.
Yeah. Nice.
When we realised that people were liking that as well, then the collection did sort of expand pretty quickly.
Give them what they want. Yeah.
You have to. You
Yeah,
have to.
absolutely. So the company started off, and you started putting content out there. Were you surprised by the way that it sort of took off and grew? You obviously knew what you were doing in terms of the maths, and you knew what you were doing in terms of the content production side, as you say, with Jack. And I have to say that the graphics that you guys use as well, sort of the images and the representations, which we'll get into in a moment, if that's all right, are really engaging and
Oh,
eye-catching and
thank you.
colourful as well. As I say, there's a very definite brand, isn't there, and aesthetic to it, that appeals, it seems. But even given all that expertise, were you sort of surprised by the way that it's grown?
Yeah, for sure. I think it certainly, we didn't grow. It took a while to get to the point where we are. I think we started on social media maybe the end of 2019, and then
Okay.
we got wrapped up in another project, so we didn't really do anything for about a year and a half, and then we came back into it, I want to say about 2022, 2023.
Right.
So yeah, it was always a tricky one because maths is one of those subjects, isn't it? People tend to be on one end of the spectrum. They either love it or they hate it. And so we knew that it wasn't necessarily going to be an easy sell for people. So in that sense, I think what surprised us the most was that such a large part of our audience don't like maths. And I know this because they tell me all the time. And
Yeah.
so the fact that, you could, if you do a maths channel and you manage to reach the people that really love maths, that's great. But I think to be able to reach so many people that maybe thought maths wasn't for them, and we're hopefully playing a small role in helping to change their minds, that's been the biggest surprise and the biggest delight of the whole thing.
It's really interesting because we know culturally that it seems to be acceptable to say I don't like maths or I can't do maths, or it's not my subject, in a way that perhaps, as typically we would say, reading is not. People, if you struggle with reading, it seems to have more of a stigma attached to
Yeah.
that than it does to say that you can't do maths. And yet maths is such a huge subject, it seems sort of bizarre to write off the whole thing. But
Yeah.
again, sort of culturally, that seems to be the case. Why why then do you think that people engage so much with what you do, given that they've already decided that it's not for them? I mean, it seems a strange, a strange tension.
Yeah, no, it's the big question, really. I think you're absolutely right about the way that people talk about maths. It is a little bit different. And there was a point where I thought people were maybe wearing it as a badge of honor. There was almost it felt like very, very quick to say that they weren't good at maths or whatever. And then I realized, actually, I think it's a suit of armor. It's a protective thing that people do, because maths is one of the few subjects that we're very frequently and very publicly tested on. It comes up, like you say, a lot. And I think that's quite terrifying, because if you go out for dinner with your friends, your knowledge of covalent bonds very rarely is going to be required. And if you've forgotten how many electrons...
We obviously move in different circles.
Oh, sorry. Yeah,
Dominique.
I can imagine that probably is a frequent topic for you, John.
Yeah. I don't even know what they are, but yeah, that's fine.
And you wouldn't necessarily be expected to. I think if you don't have that knowledge to hand, no one would be surprised.
No.
But when it comes to maths, because it is everywhere, because we're constantly having to split bills or work out discounts or do our finances quite publicly, we can feel a sense of fear. Oh God, it's my time to now do this mental maths and I don't know how to do it. So we very quickly get out to the group, I'm not good at maths, this is not my field. And then we're sort of safe and hopefully someone else would do it. So I think that's what happens. That's why people are so quick to say it. And also because it's one of those subjects where it feels very much like there's a right answer and there's a wrong answer, that's equally terrifying. And I think that it can go wrong for so many people so early, and it doesn't really need to.
Yeah, that sort of instant failure it is a scary thing, isn't it? It's and often, unfortunately, I think that happens quite early on in school. You can be put on the spot, and if you don't know the answer, the teacher moves on to somebody else, and you're sort of left there. And I know a lot of people that have been on the show have talked about memories of that. Some of them from 50 or 60 years ago,
Yeah,
that have
it
stuck
stays
with
with
them.
you. It stays with you.
Yeah, absolutely. It's interesting. I was also talking to another guest just earlier this week, actually, Emma Lockhart, who's a secondary maths teacher. Um, she was talking about the same thing, actually. And even as a mathematician, that feeling of when you're out to dinner and somebody says, right, it's time to split the bill. Who's the mathematician here? Okay, it's obviously
Yeah,
Emma, and that's your job, because everybody else has washed their hands of it already. So it's interesting that is culturally still a thing, but hopefully, the work that you're doing and the work that we're trying to do and things to raise the profile and as you say, make it feel like it's something safe and that everybody can actually engage in. Because you're right, maths is all around us. It's how the world sort of works, isn't it?
absolutely.
Um, and for me, maths is the thing that helps you to know what to do when you don't know what to do, in terms of problem solving and things. It's the skills, I think, that you can learn through learning maths that can help you in situations that become unfamiliar or, non-routine, I suppose.
No, for
Um,
sure. I completely agree.
so one of the ways that you do that very well is when you're talking through a particular concept. It could be times tables, could be percentages. I've seen quite a lot of your videos and things on those. We've mentioned earlier Jack's sort of expertise with graphics and the design and things. He brings to life some really useful and helpful representations, I think, that tend to come up on the screen. Can you talk me through how you arrive at those? Is that a sort of collaboration between the two of you? Do you do the math side and then Jack makes it look enticing or engaging? What's the process?
Yeah, it's definitely a collaboration. So I do take care of the math side, but we very often talk through how what are the different ways that we can help someone to for this to click, because I think our brains do tend to work differently. An explanation that appeals to somebody would be complete jargon to somebody else, and we're quite fortunate in the sense that I had the traditional maths success story at school, and Jack
Yeah.
didn't get on very well with maths at school. But actually, whenever I, teach Jack a concept or anything, he's got a great mind for mathematics, as most people do have. They just don't realise because maybe they've been put off by, not getting the right answer all the time or all the things that we mentioned before. Whereas he asks a lot of questions. He really wants to get to the heart of it. And that can really help as we're discussing different problems to see, okay, well, certain explanations might work for me. I'll very quickly, if there's a problem or a puzzle, I'll go to, a very algebraic solution. I'll get it written. Whereas he might see things more visually or think, well, what's the more practical way of doing this? And so we talk through these things and we think, okay, how best can we express this? What's the most physical way? I think a physical representation almost always helps for all people
Yeah.
in every situation. So we do tend to get a bit more theoretical maybe in the caption so that people have that if they need it, but also we'll try and find, we'll try and use color, we'll try and use sound effects, we'll try and use everything that's available to us to make it as alive as possible so that people can have those aha moments with whatever it is we're dealing with.
I think they're just great examples of things that we've talked about in education for the last sort of 10, well, much longer than 10 years, but it's really come to the forefront in the last 10 years with the work that the maths hubs and places like that have been doing that lots of teachers listening will be familiar with. So there's an approach, a pedagogical approach that relies on concrete manipulatives and then pictorial representations, and before moving to the abstract and then moving back and forwards between those different representations. It's not necessarily a linear progression
Sure.
through them. I think what you guys do brilliantly is the use of colour and things. The colours are linked to any numbers and things that are represented in the equations and things that you have on the screen as well. And it's really clear in how the representation links to the numbers. I think sometimes where we get lost is, I was working with some students yesterday and we were doing division, and I had to show them how to do long division. These are teaching students who many of them again would say that maths is not necessarily their strong suit. Some of them absolutely brilliant and very confident, some of them less so, as you would expect in any sort of cross section, I suppose, of society. but most of them hadn't come across long division before, and so because it's in the curriculum, we have to show how that works. And just sort of working out where the numbers have come from can sometimes be really confusing. But I think one of the ways that we can make that much clearer is through the representations, but also using colour to link, so we're not just pulling these numbers out of thin air. You can really see where they're coming from. Was that something you'd done before, or was that just something that sort of intuitively made sense to you?
Yeah, I think it just made sense to us because we've got a background in the visual arts. I think those were things that we were always thinking about, even in our previous work. So it made sense to apply those. We know, we know so much about things like colour theory and how different representations affect us. So it did make sense that there could be an application for that, and particularly because we're making videos and we're not in a classroom where that you might be restricted in that sometimes. We did have so much available to us to be able to bring these things to life. And what you were saying about, moving on to the abstract later, I think sometimes because numbers are all around us, we forget quite how abstract they really are.
Yeah.
And I mean, obviously the idea of quantity is inherent in the universe, we know that, but our representation of them is completely human made. There's no reason really for why the number 8 looks like the number 8 other than, well, we sort of developed a system. And I think when we're
there's
learning
probably a
that,
video in there as to why the number 8, it looks like the number 8.
we've done one actually, I think.
Yeah, well, there you go. Yeah.
There's one somewhere in the archives.
Search that on TikTok or Instagram,
Yeah.
it'll be there.
But we forget that sometimes when we're teaching for the first time, or when we're students encountering it. It just seems, well, it's obvious. That's what we called it. And I think for many of us, it can be a bit of a leap, or it should really be a bit of a leap at some point to go, well, why did we decide on these 10 symbols? And how else can we represent it? Because it is so abstract that it's understandable that when you take a student of any level and they look at that abstract representation of a physical problem, there's so many places where they could be like, this doesn't make sense. So if you can show it in many other ways, if you can show it physically, if you can turn numbers into dots and other representations, again, I think you open up the possibility for everyone to get a hook onto it, whichever thing makes the most sense to them.
Yeah. Absolutely. And I think there's a lot of teachers that would agree. And as you say, there are different levels as well of abstract. So you've got numbers themselves, which are, as you say, human made, even though they're sort of labels for things that exist, I suppose. But yesterday, again, after a little bit of long division, which we started the day with, because why wouldn't you? The rest of the day was all around fractions. We were sort of thinking about why is fractional thinking or the concept of fractions tricky for a lot of children to understand. And when you think about it, for fractions, we begin to learn about fractions quite early on in terms of halving things, sharing things, that sort of thing. But really, understanding fractional notation and things like that really comes in about year 3, so when children are about 7 or 8 years old. Up until that point, we've learnt about a number system that works with integers, and it is very simple, and the larger the number, the larger the value, and all of that. And all of a sudden, we introduce this whole other system, which is not as intuitive as that. So, when you've got a third and a fifth next to each other, it feels like, knowing what we know about numbers, that the fifth should be larger than the third because 5 is greater than 3. But actually, it's the other way around. And again, I think if you've got that internalized representation of actually what a third looks like, and again, using pictures and models and that sort of thing can really help with this, and what a fifth looks like, then children know that if you cut a cake into 3 pieces and you cut a cake into 5 pieces, if you've got a piece of the one that's been cut into 5, you've lost out, haven't you? Everybody wants a piece from the cake that's cut into 3, if they're the same size cakes.
If they're equal.
Yeah, absolutely. Yeah, and that's the other thing. So, just understanding that a part can be part of a whole, and that they've got to be equal pieces, and all of that. There's so much to unpick with that, and I think anything that we can try and make that less abstract, and actually remember that it is just how how we do things every day. But we give these names to them and come up with a system for how they work.
Yeah, for sure. And I think it's another reason why it's so important that we do focus on the maths that they will need to solve the problems they come up against. And this might be slightly controversial, but some of the things that I feel we cover at an early age maybe don't need to be there just yet. And I'm certainly not saying that maths should only be the things that we come up against in life, because I think that there's some, I think when it comes to math, there's a huge amount of it is incredibly useful, and that's important. But some of it is just beautiful. It's just incredible, and that's also important. So I'm certainly not saying that we should only focus on what's useful, but there are some parts of it which maybe for a younger student or a less advanced student is not necessarily that immediately useful for them, and not necessarily open to the most amount of exploration and discovery. And I feel like it's sometimes just in the curriculum to complete a set of things. And perhaps those things might be very often the sticking points for people. The parts where, well, that doesn't make any sense. I don't know when I'm going to need this, and it's not giving me any joy in the discovery.
Yeah.
And I do sometimes wonder if there are a few topics that maybe we cover too early.
I think many teachers would agree with you. And in fact, just recently, you may or may not be aware, there's been a curriculum and assessment review where they've suggested what a new national curriculum might look like in 2027, 2028. It's due to come out. And there's some suggestion that Key Stage 1, so Year 1 through to Year 9, Key Stage 3, will be sort of rejigged a bit so that things are in a more sensible order, and some things might appear later in the curriculum. But you're absolutely right. I've, as regular listeners to the show will know, I have mild PTSD from my very first teaching placement, where the very first thing I was asked to do in maths was teach some 6-year-olds how to read an analog clock. And yeah, I thought, well, that's easy. We all know how a clock works. It's fine. Big hand, small hand, minutes, hours. All of a sudden, as you're doing it, you realize how complex that really is, in terms of all the one means 5, and we're counting in 5s and 10s, and then we've got quarters and halves and past and 2. It's that stuck with me. So my first thing would be telling the time, yes, but let's start with what they're familiar with in terms of digital clocks and things, because we see those everywhere now.
No, exactly.
And save analog until we've mastered, counting in 5s and what quarter is and what half is and what those things really mean.
It's a very complicated topic, and we're just mastering dealing with base 10 and figuring out why we picked base 10, and now we're in base 12.
Yeah, exactly. Yeah. And it's fascinating because I love, we did a whole little episode on the history of time and how we ended up where we did. And we know that in France they did have a go with decimalized time and base 10 time, and it didn't really catch on. Nobody seemed to know where they were at any point during the day or where they were supposed to be.
There's still a group that advocates for base 12, aren't there?
Oh, really? Oh, I don't know.
Yes.
Oh, okay.
I was reading about them recently and I've forgotten.
I will look into
it. Have a look, because they're petitioning for because times tables do become quite a bit easier in base 12.
Well, times tables are another area. So, earlier when you were saying that you felt that you'd not mastered, but you'd got as far as you had in maths by having a very good ability to memorize facts and procedures, perhaps, and knowing, how to follow a line of calculations or whatever. I always struggled at school with memorizing times tables. And again, I was thinking about this yesterday with fractions, how if you don't have a knowledge of your times tables, fractions are so hard to work with, because, if you need to find an equivalent fraction or you need to simplify a fraction and things, if you don't have your times tables knowledge, it's so hard to see the connections between the numbers. Lots of children seem to struggle with times tables. I know you've done quite a lot of work on them. If you were going to give some sort of general advice about the best way, another way rather than just repetitively learning them by rote. What might you say, Dominic? Just put me on the spot there a little bit.
I think, well, firstly, I think that they are a really pivotal moment in education, and I think it might actually be the times tables that will decide whether someone likes maths or not. For so many, I think that you're absolutely right. They're very important, and we do struggle to move on, to advance, if we can't calculate quickly. So I do understand why we really want to get across, that kids have those facts pretty automatically. But we put so much pressure on it. We put, countdown timers and stress. It's like we're
Yeah.
in a Die Hard movie. Like the fate of the universe rests on us knowing the answer to 7 times 6. So I think that a balance would probably be a good place to start. But also, I'm sure that there aren't very many teachers who are just going straight into memorization. I don't think that's a thing anymore. At least I hope it's not. I think in my day it was just, memorize these. And a lot of people will still be like, in my day we just got on with it and memorized it. Well, lots of people don't like maths, so maybe it wasn't the best approach. So I think what we do need to start with is always try and start with an understanding. What is it? Why do we have it? How is it different to addition? Why did we need a shortcut for addition? What happens when we try and add a number a bunch of times or scale something? It's not very convenient, so we found a way. And I think by making sure that it's linked with addition and with counting, everyone's got an in then. You know that, well, at the very least, I can count all of these dots and I will be able to do it. So that takes off a bit of pressure. Then when you can add, you think, okay, well, if I can add, then I can multiply. That takes off a bit more pressure again. But then I think when it comes to the multiplication table, we do need to talk about the patterns that appear, because you can quickly reduce 144 multiplication facts down to 78 just by talking about commutativity. So when we explore that already takes, half the pressure off. And then looking at those patterns in each table, seeing what happens when we multiply by 10. What is that fantastic one fact that we need to master to get all the 10s? How does that then link to the 5s? So now, really only 2 facts we need to know to cover 2 times tables. The 11s as well, great pattern there. That's just one more fact. So we're not actually having to learn anywhere near 144 things, even if there is an element of memorization. Yeah, of course, we're going to have to remember certain things. Learning how to double, that's probably one of the most vital parts. If we can double quickly, we can tackle most of the others. So I think reducing the task and looking for the patterns and making it fun and applying these little, they're not tricks. They are just what we are doing in multiplication, but giving students those things, showing them where the patterns occur, I think could take off a lot of the stress of it and make it actually something quite fun.
Yeah, no, I agree. We'll come back to tricks, inverted commas, in a moment, if that's okay, because it is another thing I wanted to just talk to you about. But I think for me, one of the things with times tables is that there isn't one right way to learn them, as you say. And as you say, if you've got that understanding, then there's ways into it. So for me, it happened to be square numbers. I seem to be able to remember square numbers. I knew 5 5s, I knew 6 6s, 7 7s, seemed to just stick in my head for some reason. But if I knew those, then, as you say, there was quite, without doing too much calculating, there was a way into a lot of the others. So if I could work out 7 7s, I could work out 6 7s and 8 7s and things just by doing a little bit of adding or whatever.
And also, amazingly, that the one either side of a square number is just going to be one less than it. So if you know that 6 times 6 is 36, then 7 times 5 is going to be 35. So that's another incredible pattern that, because
I wish somebody had pointed that
numbers
out to me about 40 years ago, but or 30 years ago. I'm not quite that old. So I think just being aware that there isn't one way, and chanting times tables is one way, and for some children it will work that way, but for others it's just going to turn them off because it feels like you've just got to remember all these numbers that don't mean anything. And then again, just to go back to fractions, when it comes to fractions, having that understanding of why multiplication works in the way that it does makes it so much easier to know what to do when you've got, I don't know, a fifth times 3. Well, it's just, if I understand it's, just a fifth plus a fifth plus a fifth, that all makes sense. I can do that. It's 3/5. That's easy. But it looks really foreign and strange. And do I do the same to the top as I do to the bottom? And all those sorts of potential tricks, which is what I'd like to talk to you about now. Though, do the same to the top as you do to the bottom. Well, that works sometimes, but not always. And if you don't understand why it works, then it might not be helpful. I definitely remember sitting in a GCSE exam looking at some incomprehensible fractions and thinking, okay, I know I need to do the same to the top as I do to the bottom. I have no idea if that was actually what I needed to do or not. One of the things that people do love about your content is that you do show, I don't want to say tricks. Sometimes they seem like tricks. Sometimes they shortcuts or just another way of looking at it. Let's say, do we need to be careful sometimes that there's, and I have to say you are very good at putting the understanding with it. Why does that work? It's always there. Why does this work? And then you explain it. Do you think that's the key bit that sometimes is missing from these tricks or tips and things?
Yeah, possibly. I think, these maths tricks tend to get a bit of a bad rap. And understandably, I think there's a bit of apprehension about, will students understand what they're doing, or are they just following a procedure, and do they always work? But I think it depends on the technique and how we present it. So in a sense, every algorithm that we learn is a maths trick. Long multiplication is a maths trick. If we didn't have it, we would be adding streams of numbers. And it's an algorithm that we learn, and also one that we sometimes learn by rote and don't understand what we're doing. So really, when you compare them, it all depends in the presentation, because long multiplication can be an incredible tool if we understand it, if we know why it works. And we understand that, it's a shortcut for what would otherwise be a really tedious procedure. And it's no different from any of the other tricks that get a bad rap. Obviously, we don't want anything that, comes from a coincidence that really doesn't work and you just spot it for a couple of numbers. Those don't even count. It's not maths. It's more like a joke. But something that really is grounded in solid maths that we can explore, that we can understand why it works, they can actually enhance our understanding of what's going on. And I don't want to butcher your fantastic quote from earlier, but you said something about we do maths to understand what to do when we don't know what to do. You said it much more succinctly than that.
That was essentially it. It wasn't that profound. It was
it was great though, and I think that it really cuts to the heart of what are we learning all of this for? Because whether it's a more conventional technique like long multiplication or a less standard mathematic trick, if we are just learning an algorithm, what happens when we get into the real world and there's no algorithm for the problem that we're facing? Then how has our mathematical education prepared us for that situation? And I think we've missed something there if all we're ever doing is repeating procedures, whether they're the ones that are considered standard or non-standard. We're then not encouraging our creative thinking, our exploration. And so these other methods, I'll call them, I don't want to separate them, because I think that all of the methods, they have their place, but some are certainly the ice cream and some are the sprinkles. You need the ice cream before you can have the sprinkles, and you do need to have an understanding of what you're doing. But if we have the time and the space to explore different ways of doing things, to see how does that add to our picture of the concept that we're looking at, not only do we make sure that students see that it's fun, that they've got choices, that they can do what seems to appeal to them.
I suppose to sort of summarize what you were saying, Dominique, is that if sometimes these different ways of looking at things can actually be a way into the understanding. So if you can foster some curiosity about, well, this works, that's really interesting, isn't it? It's like the commutativity of percentages, isn't it? Which I know it was a really popular, it seemed to be a couple of years ago, everybody went, oh, wow, you can swap the numbers around and it still works. And, if you can then take that and say, well, why does that work? Then you've got an opportunity to really develop some understanding. And I guess the other thing is that we talked earlier about confidence and people not feeling confident about maths and things. And if there is a way to do it that makes sense to them, then surely that's a better thing than just sort of saying, oh, no, it's got to be done in this particular way because this is the best way.
Yeah.
Whilst always having that idea that actually, it would be great if we could actually understand why that works, because that will help you to make connections that otherwise you might not necessarily make. And when I think about my own maths education, I think that was what was missing. I saw everything as completely discrete and not connected at all. And actually, as an adult now, I realise that one of the beautiful things about maths is how interconnected everything is. And if we can help people to see that, it makes things a little bit easier for them.
No, for
So,
sure. And I think when we prescribe a method as well, we're giving the impression that maths is something that's done, it's
yeah,
finished. Other people did it, and now you just have to repeat it. And that's not really the most amount of fun, is it? We'd never say that in an art class or a music class. It's like, oh, all right, Monet did the painting. You just need to memorise what he did and what colours he used. So when we explore these different methods, we show students that they get to play a part. They get to have ideas about how this works, why this works, which way they like to do it. And one of the things we see so often, and I think there's some great educators who do series about how do you tackle this particular problem, and they'll put a calculation on the screen, and you see how many different ways people
yeah.
like doing it. And you might love a few of them and hate a few of them. What happens if you're only ever exposed to the ones that you end up hating? You miss out on the things that could have really got you into the subject. So I think that's why all these techniques should be considered, because they give us all a way in.
And from a teaching point of view, one of the things that I used to love doing was starting the lesson with a problem and seeing how many different ways we could do it. And sometimes it would be, it wasn't even a problem. Sometimes it was just a number. How many different ways can you make this number? How many different operations can you use? Who can create the most complicated, who's got the most simple one, those sorts of things. But just giving opportunities to play with maths a little bit and have some fun with it. And that's why people like puzzles and they like problems, and Sudoku and those sorts of things are still really popular, even though they involve maths. So I know you do quite a lot with problem solve, and we see, don't we? Sorry to go off on a slight tangent, but on social media, every now and again, these problems will appear that have got people scratching their heads. Often it's somebody's 7-year-old's homework, or that seems impossible. Occasionally is, or it could be pictograph representations of things where somebody's hidden an extra piece of fruit or something in the calculation, or of course order of operations, which seems to have people screaming at their screens over and over again. Have you got a sort of particular favorite or recent favorite problem or riddle that has had people scratching their heads?
Yeah, it's funny. I think I love riddles and I love puzzles. And yeah, we do. We receive so many, and we try and cover as many that people send us. But there are also some of the ones that you mentioned I have not so much love for, because I think particularly things like the BODMAS puzzles or the pictorial simultaneous equations puzzles, I think that they're really misrepresenting maths, and what they're doing is feeding on the exact thing that people don't like about it in the name of the clicks. And it's such a shame, because if it was a topic where everyone was just sort of okay with it, yeah, fine, it's a bit of fun, whatever. But you can very much see from the comments that, again, it just brings up all of those feelings of resentment, because people think it's just a bunch of confusing rules that don't make sense. It's just there to trick me. It's really not supposed to be that. It's supposed to be the way that we communicate, the way that we make things clear. So those puzzles I have a bit more trouble with, because I don't think they're doing good things for the PR of
I
maths.
agree. I don't think they're put out there for the purposes of people having fun or
No,
learning anything necessarily about maths either.
no,
It's so that people can argue in the comments, isn't it? And then get lots of,
exactly.
it feeds the algorithm. Yeah, I
Yeah.
totally agree.
But there are a load of great puzzles as well that really get people talking about them, that really, you see so many different ways and how people approach them, and those are fantastic. One that we shared recently, which isn't one of the ones that is popular on social media. It's just an old legend about the German mathematician Gauss, and the legend goes that the teacher asked the class to add up the numbers from 1 to 100, thinking that, that would keep them quiet for a good half an hour.
Which is what every teacher wants. Yeah, just half an hour apiece. That'd be great.
Just a bit of peace. And as the story goes, Gauss sort of solved it in seconds flat, marched up to the chalkboard and wrote the answer. And whether or not it's true, the technique is sound and it does exist. And what was done is that the sum was folded in half. So instead of adding one number at a time, as you would, if you fold the numbers in half, you can make pairs of 101. So if you think if you've got 1 all the way to 100 and you stop at 50 and fold it upside down, you'll end up with 1 plus 100.
This is where your representations are really useful.
Really
Where's Jack? Come and draw. Yeah. Sorry. Yeah. So what you're saying is that you put the 1 with the 100,
the 2 with the 99, the 3 with the 98, and in that way you end up making 50 pairs of 101.
Got you. Yes.
So instead of having to do all those additions, because when we multiply a 2-digit number by 101, we just write that number down twice. So 50 times 101 is 50. So it's something that, looks like a really complex calculation, but just because you look at it in a slightly different way, you can reduce it to seconds.
And this is the thing that I keep coming back to, that the best mathematians do the easiest maths.
That's what they say.
Yeah, because if you can see and if you can think about it creatively, and look at it in a different way, and that's what we need to. I think if we can try and encourage in the pupils that we're working with, there's always that slightly frustrating thing where, in fact, there was some really interesting research about this with problem solving. So somebody studied how long different children spent looking at a problem before they started working on the problem, and the I don't know the exact times and things, but the children who were most successful, who were perhaps described as high retaining, spent longer looking at the problem before they began working on it, and then solved it much more quickly than the children who maybe were less confident in maths, who immediately looked for a procedure to go to. And we see that all the time with I spent lots of years teaching in Year 6 with the Year 6 SATs, Key Stage 2, end of Key Stage 2 tests in May every year. And invariably on the arithmetic paper, which I've got my own issues with, but on the arithmetic paper, one of the early questions would be something like 10,001 take away 9,999. And you would see children writing down algorithms to solve it rather than just thinking it's just a difference of 2, I think, if I gave the right numbers, but rather than looking at it and thinking, what do I notice about the problem? And so I think if we can just try and instill that idea that maths isn't procedures help us, but they don't do the maths for us. We need to look at it and think around it. Then it would help so many people feel more confident, I think, about maths, and see the joy that can be in it.
Oh, completely. I think that the purpose of the maths class has also changed, and I'm not sure if we've updated, because there was a time when a calculator was a human who had to calculate. And so it was important that they knew all the procedures, all the algorithms to help them calculate. But we now have a lot of assistance for calculation. And while that doesn't mean that we shouldn't know and understand all the different algorithms, because there are times where we need mental maths, where we need to understand what our calculators are up to in there. But we're in a different world now, in the sense where our quick calculation skills might not be the most important thing anymore, but our creative problem solving is even more important than it was. So perhaps that should be signifying a slight shift in a topic that can really help us there, where the whole topic is about problems and solving problems. And if we can, instead of focus so heavily on repeating algorithms for a required result, maybe we should just see, okay, well, how else can we solve this problem?
Unsurprisingly, I completely agree with you. And I think actually what you were saying there about, we've always got calculators with us now. I've got one next to me. Well, I've got one in front of me. It's all over the place. Things that do these things for you all the time. So helpful. But it's knowing when to use those as well. So Again, going back to that calculation that I just mentioned in the Key Stage 2 SATs paper, 10,001 take away 9,999. I would hate to be getting my phone out and writing that down, typing it in to do that. There are times, aren't there, where a mental flexibility around number can really help you to solve things. And I do lots of work with partitioning and things, and I know you do as well from your videos, to make things easier and in a way that you can do a lot of those calculations really quickly in your head without worrying about it, particularly if you don't need an exact answer. We're just looking for an estimate. If I'm going shopping and I know how much money I've got roughly, I can estimate whether I can afford what I'm buying and those sorts of things. But if it's a really big number or too many numbers to hold comfortably in my head, that's where the tools and the things are more useful. And you're right, these days, calculator more useful perhaps in some ways than a formal written method. Even though I would say from a pedagogical point of view, sometimes learning the formal written method can help us understand how the number system works a little bit as well. I think there's something to be said for that too.
Yeah, there's a place for it all, and algorithms are incredibly important in everything, and so we do need to learn how to follow a procedure to get a result that can be relied upon. It's an important part of the educational process, but we also need to know what to do when there isn't one. How do we approach? Otherwise, we'll never solve a new problem again. So it's a bit of column A and bit of column B, I think, is a good approach moving forward.
That seems to be life in general, I think.
Yeah.
Interestingly, from what you were just saying, again, another focus of the curriculum and assessment review is indicating that problem solving is going to be a much higher focus in Key Stage 2 in a new national curriculum. It's already one of the three main aims of the national curriculum as it is: problem solving, reasoning and fluency. But it looks like problem solving is going to be given a much higher profile, which I think can only be a good thing. And as you say, it is fundamental to maths. That's one of the reasons that you might want to learn maths is to be able to solve problems.
Yeah.
And not just maths problems. I think the skills that you learn solving maths problems are just useful for life in general, aren't they? Resilience, thinking, reasoning, justifying, conjecturing, all those good words.
Yeah, no, I couldn't agree more. It's so widely applicable beyond calculation.
Absolutely. Dominique, thank you so much for your time this morning. I really, really appreciate it. It's been fascinating talking to you. If people
Thanks for having me, John. It's been great.
Yeah, no, thank you. If people would like to find out more, where's the best place to go and find you and Jack and your work?
Yeah, so you can find us on our social media platforms, Sums of Anarchy on Instagram and YouTube. I think with Sums of Anarchy Official on TikTok. Our website, sumsofanarchy.com. You find all of our books and resources there. I think that's everywhere.
Yeah,
Facebook, Sums of Anarchy.
Facebook too, yeah, still there. Because you have got workbooks and other resources and bookmarks and things as well, haven't you? I've seen, which are, again, all on brand and beautiful.
Thank you.
I'm sure very helpful and engaging.
Yeah, we hope so.
Brilliant. Thank you so much. I will be back on Friday with Becky for another Aftermaths episode where we'll dissect some of what Dominica and I have talked about this morning. And also there'll be doubtless Maths of Life or some Mathsology as well. We will see you then. In the meantime, have a great week. And Dominica, thank you once again for joining us.
Thanks so much for having me, John. Take care.